All right, welcome back everyone. This is Calculus 3. So in today's video, we are going to talk about the new chapter 4, functions of several variables. So in this topic, we're gonna keep using the similar characteristic of vector system, but it's going to be more corresponding to from one dimension to another dimensional information. So let me show you the couple information of 4.1 topic, okay? So let me go to here. So we are going to talk about function of two variable and how to identify its domain and range. And also we are going to be able to sketch the graph of a function of two variable. And also we're going to talk about the concept of level curves, okay? So let me show you the definition of functions of several variables. So just basic idea, If you guys, let's say I have a function of two variable, which means you have a function and then there are two variables such as x and y. So let's say I'm just creating x-axis, y-axis here. And then as you see that, I have x comma y as a coordinate point, or you could have any other, a comma b, or you could have any two variable. Now, what does it mean a function of a two variable? You can correspond this coordinate point into another system. So it does not need to be like a three-dimensional space. As long as you can define the input and output, that's what we call like as a function. So I'm going to, so this is the your let's say coordinate points. I'm going to correspond to another point. And now what does it mean? Z is going to be function of two variable. Or you can say you have a comma b, this point will be corresponding to another k equal to f a comma b. So we call this is a function of a two variable. Now I said z equal to f of x. This is maps each ordered pair x comma y, subset D of the real plane, the two-dimensional space. So this is a two-dimensional space because we have a two, variable. And we call, so we have a two relationship going, right? One is from the left side to the right side. We call whatever the information on the left side, we call this information, we collect. This is a domain of the function. And then what now you're corresponding this domain through the function and you got the outcome, this is going to be your range. So a little bit abstract concept, but it's just simple. You can think about input and output, but now your domain is passing through the right, whatever the function. It could be, any function. You're passing through this system and you will get the outcome. And then when you collect all the possible z, you can have a z1 through the z infinity or k1 through the k infinity. Whatever those, all the outcomes are going to be in your range. Same thing, your domain here, you have infinite number of this, coordinate points. It could be, I don't know, a comma k or h comma z. These are going to be mapped to another system. So that's going to be domain and range relationship between the between two variable, and we call this is a function of two variable system. So it's a just similar domain and range. So I'm gonna here the set D, as I mentioned here, D is a codomain of the function, and range of F is a set of all real numbers Z that has at least one order pair, right? So we're gonna talk about this relationship more and more. We're gonna expand this knowledge into three-dimensional or multiple several variable system, okay? So I just show you the basic idea, the function of two variable, including x and y. So let me show you the example, okay? So here is the example one. So when you have a two dimension, it's pretty simple. Okay, I have f of x comma y. This is the function, radical x plus y. So whenever you have a coordinate point in the domain, right? It could be a comma b. Now you're going to passing through fx comma y. They say it is going to be radical x plus y. And then you're going to find out the range. So you're plugging in a into x, b into y. So radical a plus b, that is going to be your one of the components of the range. So this is a relationship we are talking. So let's look at the question, letter A. Very simple. Find out the outcome when x4 and y is a 3. So this is the given function. We're going to just passing through this function system. So simply f comma 4, 3, this. So now I have a 4 comma 3. You're going to plugging in this one into the function and you will get the that's corresponding the outcome. So we can calculate that simply radical 4 plus 3, 2 plus 3, so 5. So f 4 comma 3, these are the range and this is the coordinate points. Now your outcome is simply 5. So they're corresponding to each other in terms of this unique function. Okay, so that's what they mean. You, depending on your function, you can get a one, sole number, or you can have a multiple number. But in this case, your function is a simple radical x plus y. So when you're plugging in, this coordinate points is corresponding to this number in another system. Okay, so we just got that information. So the answer is 5. Same thing. So now your function is more complicated. So now your function is going to be 2x minus 3y plus ln xy. Your domain is a coordinate points, all the collection of the coordinate points. And this time I have 1, 1. I want to find out the corresponding outcome. So just plugging in, right? f 1, 1, 3, 1, ln 1 times 1 is 1. Always we know ln 1 is a 0. So 2 minus 3 is a -1. So what I got? f 1, 1. This coordinate point is corresponding to -1 in this functional system. Okay, so that's what they mean. That's what they mean. We are going to expand more and more into 3 and other variable. So that's the basic concept, right? It's a very similar because we are talking about function. I'm gonna go to the next example and let's take a look at it. I'm gonna go down slowly. All right, so in this question, they want you to define the domain and range of the following given function. So here, they didn't give you a specific, a comma b. We don't know what the possible, coordinate points in the domain, but they're asking you find out the domain, which means you have to find out whatever the possible, coordinate points they're satisfied with this function, and then also the range. So we're gonna step by step. This is still, we know that on example of a linear, this is a linear form. This is a linear function in 2 variable because I don't see any second power, third power. This is just a linear in 2 variables, okay? And then there are no values or combinations of x and y that cause f of x comma y to be defined, right? Because it could be any number right now because they didn't specifically what the, find out the specific outcome at whatever point. They didn't give you that information. We don't know the value or combination of f of x comma y. So what is a domain? So the domain literally just all real numbers of f. You can choose any number for f of x. So therefore the domain is going to be all real number. Okay, or it's the same meaning in second dimension in this case, because it's a linear function in 2 variable. Okay, so we found out the domain. So also we need to define the range. To define range, what are you guys gonna do? It's a little bit tricky, but we can keep developing the idea. Whatever 3x plus 5y plus z, not the z, 2. That's a 2, right? The outcome. This one is going to be all the possible numbers in the ranges, right? So I will say this one is a z. Just randomly, I created a number z. Let's say that is a z. Okay. So you can keep writing. I'm gonna say one. First of all, one such a solution can be obtained by setting y equal to 0, which is, if you plugging in 0, I'm just trying, you can plug in any number because a domain can be any real number. So let me plug in 0 into y. So we're gonna get 3x plus 0 plus 2 equal to z. And then if y equal to 0, we can solve for x. So it means 3x equal to z minus 2, and you can divide it by 3. X will be z minus 2 over 3. Okay, so what does it mean? Now you have order pair. What happened? X is a z minus 2 over 3, comma 0. This is one of the coordinate point you can find out, by modifying the y, into 0. Okay, so this one could be our one of the coordinate points. So what do you notice? Since x and y can be any real number in this question because it's a linear, thus whatever the outcome, the range is also any real number. So in this question, the domain and range both are real number in 2 dimensions. That's the answer. So just I wrote a lot, but the idea is, what are the possible numbers for the domain? What are the possible outcomes in the range? So since the characteristic first, you need to check this is the linear function. So in linear function, we don't have any limitation. If you have like a radical, the inside of the radical should be positive number, but linear, we don't have any limitation to be domain or range. So simply the answer is just all real number, but I wrote more details. I choose one of the number. You can find out any, coordinate points in this system. So as I observe, any number can be possible. So both the domain and ranges are real numbers. So that's the answer for letter A. A little bit of writing, but you see what I'm talking about. So I'm going to hold up here because it's important. We need to define domain and range. Later, we're going to do a little bit complicated things, but here, let's step by step. Are you guys okay with the letter A? I mean, I just wrote a lot, but let's take a look at B. Let it be. So let it be. Okay, this is not the linear function. So we know that there's some limitation of determining domain and range. What do we know? The inside of the square root, inside of the radical must be positive number. The fact, right? The inside of the radical should be greater than or equal to 0. That's the fact. It cannot be negative number. So therefore, we can say 9 minus x to the second minus y to the second should be greater than or equal to 0. So I want to make it a little bit beautiful, this equation. It looks like a circle function. So let me move 9 to the other side. So negative x second minus y second is greater than or equal to negative 9. Now you can divide it by -1 everywhere. So once you divide the negative number with the negative number, you have to switch over the inequality. So actually you will get x second, y second is less than 9. Dun, 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 dun. So from here, we can find out a big clue of determining the domain. So here, this is the domain. So therefore, the domain of what function? F of x is, we're going to write that way. You can have any x comma y in a real number such that as long as you satisfy x squared plus y squared is a less than or equal to 9. This is the domain of this function. Let me read it one more time. So this is a mathematical sentence. You can think about it. We are looking for the domain of the function f of x comma y. You can choose any coordinate points as a real number. This means such that as long as x squared plus y squared is a less than 9. If you satisfy with that coordinate points, yes, that's going to be your domain of this function. Okay, so we can actually graph. We can graph this information because this is a circle equation, right? So according to x squared plus y squared equal to r squared, this is a circle. So x squared plus y squared less than 9. We have a radius 1, 2, 3 up, 1, 2, 3 up, 1, 2, 3 left, down. This is the circle, right? And then you can have any coordinate point. Where's your domain? You can have 1, 1. It could be one of the domain. Here, you can have 2, 2. Here, you can have -1, -1. You have a many possible, coordinate points inside of this circle because it's a less than or equal to. So these are all the domain. That's what I'm saying. Okay, so we found out the domain. Okay, now the next step is the range. Okay, so one more time, domain, we define that. Let's go to the range. What is a range? So to find out the range, for a range, we know that whatever the outcomes of this function is the, the components, all the components of the outcome, that is going to be the range, right? So let me just write down f(x, y). This is the given function. 9 minus x squared, y squared. Are you okay with that? That's given. I'm going to just choose a random x and y. So let's say choose x0, y0 as one of the coordinate points in the domain. Okay, and then I'm going to plug in it. So it means choose then we have f x0, y0, 9 minus x0 square minus y0 square, right? And then let me just keep modify. This means 9 minus x0 square. I can find out the common negative number outside and then positive. So 0 second. So we can keep modifying by plugging in x0, y0. What is the fact? If x comma, we know that, sorry. So we also know one fact. From the circle equation, here, x second plus y second, it is 9, right? So this is from the given information of the domain. If then x0 second plus y0 second is going to be less than or is equal to 9, right? Because we're going to choose other random number, but it cannot be greater than 9, right? Because we have a limitation up to 9. So therefore, the number that you can have for x0 second power y0, it's going to be close to 9. It's going to be less than or equal to 9. So what I'm saying is, approximately, it is going to be 9 minus 9 equal to 0. Hold up there. Okay, hold up there. And then, what do we know? So this is a very important concept. if x squared plus y squared equal to 9, that means your possible coordinate, right? This one always needs to be positive number. It cannot be negative number. It's going to be between 0 to 9. So this one is the minimum number you can have. This is the maximum number you can have. So in this case, I plug in the maximum number. But now I'm going to plug in the minimum number. Let's try the minimum number. So if I plugging in, we have the same thing, 9 minus, x is 0 second, y is 0 second. Let's plugging in. This time is a 0 as a minimum number. Are you following? So what happened? In this time, 9 minus 0 radical, 9, 3. So that's your range. Your range is going to be between 0 to 3. Does it make sense to you? Because think about it. We already know that the domain is going to be any real number. And then the coordinate points when you square each other, as long as it's less than or equal to 9, we just consider that as a domain. But now we are talking about the range. So this is the range, whatever the outcome of this function will be the range, right? So depending on this size, because this is the size we can consider. So the x squared plus y0 squared, this is going to be between 0 and 9 only, right? Because the domain said that. It could be greater than 0, but it cannot be greater than 9 anymore. The maximum is a 9. So I put two options. One is a 9, another one is a 0. So the outcome is going to be 0 to 3. What does it mean? The range of this function f x comma y is between 0 and 3. So the notation is going to be, this is your range. So that's the answer for letter B. You can find out the domain and range of that. I hope this is not complicated. You can manage that. So that's the how we're gonna solve letter A and B both. Okay, so does it make sense to you? I hope that I'm not talk too much. So I'm gonna hold up here. Think about it. And then now I'm gonna do more shortcut. I'm gonna show you shortcut. But are you okay with that? What we are doing letter A and B? Just a little bit of writing, but can you show me your thumbs up if you got this concept? Are you guys doing okay? Okay, I see a couple thumbs up. So think about it. It's pretty makes sense. Let me try to letter C. Okay, letter C. Ooh, there's an exponential function. So let's just think about a little bit simpler way. So I'm gonna go down slowly, and then I will write down the question here. Oh, I need more space. You know what? I will minimize a little bit. Oh. Okay, I'm gonna minimize a little bit. Okay, so let's just see. Okay, I'm gonna here C. The C, the given function is f x comma y e to the negative x to the second plus y to the second. I just want to find out the domain and range. So as we know, x and y, do we have any limitation as an exponent position? For any exponent, we don't have any limitation. It can be positive number, it could be negative number. If you have a positive number, that means your outcome is getting larger and larger. If your exponent is smaller, your outcome is getting smaller, smaller. Do you remember the growth and decay concept? So x and y basically can be any number. It can be any positive, any negative, or 0. So therefore, the domain of this function, okay, is going to be, you can choose any coordinate point such that x and y both in any real number, which is just 2 dimension. So your domain of this function can be any real number. That's it, period. You could have any positive, any negative, same meaning of this linear function, right? Domain can be any number. So you can write it either that way or that way. It's the same meaning. Now, I want to find out the range, right? The range. The range is going to be just to look at the outcome. E to the negative x to the second plus y to the second. Just, you know, exponent cannot be negative number. That's a fact. So what I'm saying is, and then this is exponential. They're going to keep going and going and going and going and forever, because x and y domain can be any number. Your outcome is keep going and going and going and forever, right? So what are you guys gonna do? This is going to be between 0 and keep going infinity. So your outcome is going to be 0 to infinity. Are you guys okay? And I'm specifically looking for the possible x and y. So let's continue. First of all, so from this knowledge, I'm going to just modify a little bit. I will do a little bit backward. So we know the range is step by step. We know that the x second power plus y second power. We just know that this is all real number. And then this one, right? It's the same, greater than 0 or infinity. Okay. And then I'm trying to modify a little bit. Let's multiply -1, -1, -1 here. So it's going to be 0, negative x to the second, y to the second, and then we have a negative infinity, and then everything is a switch over to the other direction because u divided by or multiply negative. And now here, I'm going to exponent as a base, like that. So we know this is going to be 1, e to the negative x to the second plus y to the second. And then e to the infinity is going to be always 0. So the range is going to be between 0 and 1 only. It's a very interesting. You can have any real number, but the range of this particular function is going to be between 0 and 1. And both of them, this is equal here. And then 1 is going to, the other side is open. So let me just go back. So here, 0, 1, stop there. Okay, so what happened is if you go to decimal, check it out. You have here y equal to 1. They're getting, this is maybe, you can just draw this image, the function. Maybe they're going to go this way. They're never gonna touch y equal to 1. They'll keep getting close, 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 but never gonna touch. But you know, your domain can be any real number, but the range is gonna be only positive. So check it out, the decimal. My graph might not be correct, but the idea is domain range could be different. But in this case, we found out the range is going to be between 0 and 1. So that's the idea. I know. So that's what it is. So we're going to keep practicing of defining the domain and range. I'm going to hold up here. Are you guys okay? So I'm going to wait for ya. If you have any question, don't be shy. It's okay. I think Jason good to go. Who else good to go? Everybody good to go? Ewan good to go? Daniel, Matthew, Caesar, everybody okay?
Yes.
Okay, sounds good. So let's take a look at the following question. Okay. Oh, in this time they want you to sketch the domain only. So they don't ask you to find out the range. So let's think about it. Okay, just use the fact inside of the radical should be positive number. So let y minus x squared is greater than 0, isn't it? So I feel like, this is y is greater than equal to x second. Do you feel something? This is a parabola, right? So what is going to be the domain? You can graph it y equal to x, right? This is y equal to x second parabola shape, but I'm looking for only above, greater than. So the shaded area is going to be here. Do you remember this concept long time ago? And we just defining the domain here. X comma y. You can have x comma y such that as long as y is greater than or equal to x to the second. And then in the real 2-dimension. So that's the domain. Or I can write it a little bit better way. I can move this one. Can move this one here. Uh-oh. You can have this way too, okay? So that's your domain and the area is gonna be in here. You have many, you can have like 1,4, I don't know, you can have negative 1,5, right? So these are all the possible coordinate points in this domain, okay? All right, one last one. B, same fact. We know x second plus y second minus 1 greater than equal to 0. It should be a positive number. So we know, ooh, this one is going to be circle. Also, we have a second function, ln, log. 4 minus x second, y second also should be positive. It cannot be 0. It's undefined. So for the log, your x, whatever the here inside of the parenthesis, should be positive number. So if you modify this one, negative x second, I'm going to switch over the sign, multiplying negative. So I got this 2 information. So whatever the intersected between them, ooh, will be the domain, isn't it? So think about it. This is a circle equation. So the first one, radius is r squared, so 1. And then we are including equal, so everything is going to be bold. And then greater than area, so something outside. Hang in there. And then second equation, ooh, this is a 2 second power. So we have radius 2. But in this time, it's not going to be bold circle because there's no equal. So we have a dot, 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 dot. And then in this time, less than, so inside. So your shaded area exactly here, the donuts. So the domain is going to be whatever the coordinate points in between 2 functions. So how are we going to write it? The domain will be x and y coordinate points such that the x second plus y second is going to be between equal to 1, less than 4. That's the domain. Okay, so that's, you can define many different domains of the function. All right, so if you guys okay, can we continue? So 4.1 is all about domain and range, but I'm gonna keep going. It's a short topic. Can you guys show me your thumbs up? Are you good to go? Are you happy? Does it make sense to ya? Yes. So if you don't have question, let me continue, okay? So one more, a little bit complicated. Ooh, I have a couple more. Same thing, find the sketch. You're gonna sketch and find the domain. Okay, step by step, everything step by step. You have a 3 different term. So you have to define the domain of each term. And then later you're gonna find out all the intersected area as a domain. So for the first one, inside of the radical should be a positive number. So this one indicate x can be greater than or equal to 0. Second, y is greater than or equal to 0. Okay, the next one, x second plus y second minus 16 is greater than or equal to 0. Okay, I can modify. I see the circle function. So we have those 3, here, here, here. So let's draw the graph. So x is greater than or equal to 0. Where is that area? The first one, x is here. So greater than or equal to 0, which is here. X is greater than only this side, right? Go to the right side. Am I correct? And then the second, y is greater than 0, up, 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 up. Yeah. And then if you are looking at something is in the first quadrant. So let's continue. We need to use the next equation, x. So this is r second. Radius is going to be 4 everywhere. So center is a 0, 0, right? Center is a 0, 0. So you have circle like that. And then only shaded area is here in the first quadrant, but it's greater than or equal to. So this is the area. You can have any coordinate points in this shaded area. You can have any coordinate point. That's going to be your domain. So domain will be, you can have any x, y such that x should be greater than 0, y should be greater than 0, and x second plus y second is greater than equal to 16. That's the domain. And then that's the area I shaded. Okay, keep going. Letter D. Keep going. Okay, this is a fraction. So you know that denominator cannot be 0. So let's step by step. 9 minus x second minus y second should be greater than or equal to 0 because it is inside of the radical. And 2x plus y cannot be equal to 0. So let's modify that. If you modify x second plus y second is less than or equal to 9. And then if you modify this one as a linear, y is not equal to negative 2x. That's it. So let me draw the graph. So this is the r second 3. The radius is a 3. And there's an equal, so everything is a bold circle. So it's going to be inside, correct? And then we're going to draw y equal to negative 2x. The y equal to negative 2x, it's going to be this line. Y equal to negative 2x. We are not going to be equal. So you can have infinite coordinate points inside of this circle. You might have exactly the points that is passing through the line, but you cannot have that coordinate points because y is not equal to negative 2x. So we're going to skip that. You can have anyone avoiding that line. You can have any points as a domain, but you cannot have any points on this line because that is not going to be part of your domain. So the domain will be x, y. You can have any coordinate points such as x squared less than or equal to 9 and y is not equal to 2x. That's the domain. That's it. Okay. All right, so far we did the basic concept. I'm going to do a little bit of a three-dimensional space. Are you guys okay with that so far? So anybody has a question? Okay. You feel like very comfortable with this topic, right? So we're going to keep building this idea. Do you like to show me your thumbs up? We can good to go? Okay, we are good to go. All right, let's talk about it. So the next one, a little bit, but it's the same concept. Same thing. You could have just one additional, coordinate points because x, y, this is a 2-dimension. X, y, z, this is a 3-dimension, which means x, whatever number from the x-axis, y, this is from the y-axis, z from the z-axis. But you can also passing through the function and you can still define the domain and the range. Does it make sense? So one more time, we have x, y, z. This is a coordinate points. You have a given function. It could be just simple xy, or it could be xyz, whatever the function given. So you're going to plugging in and you can find out the possible outcome that is going to be the range. Also, you can have whatever the domain as well. Okay. But when you have 3 components, when you graph it, It's going to be three-dimensional shape, right? Because it's not two-dimensional anyway. So that's the different thing. Whatever the concept is the same. So let me just show you the example. It's better to understand. So I have the same question. Do you remember this example? So I want to determine the domain and range. We already know that. We already know that. So this one from here, 9 minus x second minus y second is greater than or equal to 0. So x second plus y second is it's going to be less than 9. So this is the one, this is the domain, and then your range. Do you remember the range? The radical 9, right? This one is going to be between 0 and 3. So we talked about this one. If I go up a little bit, where is that question? Right there, letter B. We have the same question. So we know that the domain is any real number. Oh, no. The domain was, oh yeah, here. The domain is between any number less than or equal to 9 when you're adding them up. So that was a domain. And we talk about the range is 0 to 3, right? But now I want to think about it as in three-dimensional space. Okay, so just the different thing is you have x, y, z, x, y, z, okay? And then the radius is 3. That means your radius is 3. So it's going to be circle. So we have a kind of like here, and then we don't see the z, so z is going to be open. So what I'm saying is here, 3 and 3, you're going to have a circle, but it's going to be, how do I draw the three-dimensional space? It's going to be something like that. Ugh, little bit circle, right? And then you have, no, we have a circle here. So it's going to be something like that. My drawing is not really great. So hopefully this is better. So this is not really like, 1 second. I'm going to try to draw better. Then we have this way. I think this is better. So this is the shape in three-dimensional space when you describe this function. So again, in this 3 space, your domain can be any number. X squared plus y squared is less than 9, and range is going to be between 0 and 3. Okay, so that's just be aware. Okay. Pretty much that's it. Okay, nothing is special. Same thing. This one, x second plus y second. We know that domain can be any real number. And then this is going to be parabola shape. So if you draw the line, we have a parabola, and z is the axis we are going to open. So we have a big circle there. And this is something that shape of this. Okay. So this is just beginning work. You feel getting more comfortable as we practice more. But I just wanted to share the three-dimensional space image. Okay. But I will do more with the following question. So let me just go to the next question. Both questions same. Why I have a star here? Get rid of it. So the same thing, draw this function in three-dimensional space. Okay, so this is in the 3-dimension. It's okay, you don't see the z, but we know what's going on. Fx, y equal to 3. That means this is, some coordinate points is corresponding to z in another system. So in this case, this is equal to 3. So what does it mean? Just z equal to 3. So when you draw the line, x, y, z, you have a 3 here, passing through here, right? So this is z equal to 3. And then you're going to create a plane. So this is the plane. If you imagine, so this is the plane z equal to 3. Okay? So think about it. That's what they mean. F of x, y equal to z. We just talk about the definition. It is corresponding to another number, but they say it is a 3. So now z is just a 3. I want to sketch that graph. So there's a line that is passing through z only. And then this is the plane. You can think about, you can imagine that cover is equal to 3. So this is going to give you the plane, simple plane. Okay. Second, okay, it is a linear. That's okay. I'm going to modify a little bit. We know that this f of x comma y is corresponding to z, but now z equal to 4 minus 2x minus y, isn't it? So let me modify a little bit this information. So it means 2x plus y, I can move to the other side, plus z equal to 4. So we can draw this line, same thing, yx, xyz. So just be aware, this is pretty much like a plane shape. On the x-axis, 4 divided by 2. You have a 2 here. And then here we have invisible. So everything, you have a invisible 2, 1, 1. That's a coefficient. So what I'm saying is you're going to divide it from here. So 4 divided by 2, 2. That's the point on the x-axis. 4 divided by 1 is a 4. 4 divided by 1 is a 4. So on the xyz, you have a 2. Y-axis, you have a 4. Z, you have a 4. So you're going to connect those 3. So this is a triangle plane. So this function going to give you the another plane like a triangle. That's it. That's how you're going to draw the image. One last. Okay. This is the same thing. F comma xy, it's going to be z. But now that z is x second plus 9y second. So if you remember the quadratic plane, this is the one of the ellipse shape. So if you draw that image, y, x, y, z, the z area is going to be open. And then you have getting, as x, y increase, z is getting increased as well. So they're getting wider as x, y increases. So this is the shape, something you can imagine. Ellipse. Okay. So that's all the possible images and how to find out the domain and range in both 2 and 3 dimensional space. So that's it. That's pretty much main idea 4.1. I'm gonna continue the next final question. It's a little short topic. Can I go to next page? Are you guys okay? Okay. So it seems like you guys doing right. So think about it. I strongly recommend you to read textbook 4.1. My lecture is based on textbook. You can see the same questions, similar concept, everything is similar. So you can practice more if you want. So I try to extract the important part from the textbook. So next concept, what if we have a more variable? So let me go there. Okay. So as I mentioned, you could have a more variable, not only just x and y, but also you can have x, y, z, or you can have x, y, t, because time could be another variable. So I'm just putting some of the example, f of x comma y comma z, you have a very complicated, but this is still function. And then you're going to find out the corresponding, whatever the outcome in the 3-dimensional space. And then you could consider one of the variable as a time. So what I'm saying here, depending on the context, you could have a 3 independent variable, or you could have 2 variable is rely on the time. So as the time goes on, 2 variables are changing at this, altogether. So that's why in the function, you could have more than 2 variables. And then how to find out the domain and range? Uh-oh, is it something new? No, it's the same strategy. Don't be scared. Just the same strategy. We have a 3 variable now. Find the domain. So we know according to the fraction, 9 minus x second, y second, z second cannot be 0, right? Denominator cannot be 0. So they have to be greater than just 0 because this cannot be 0. If it is a 0, it's undefined. So we usually know inside of the radical, is it greater than or equal to 0, but we're going to remove the equal 0 case. So that's one thing. And what else? We know we can solve it first. So x second plus y second, z second, change the inequality and 9 there. So that's one possible. And then I know from the numerator, x, y, z can be any real number. So and x, y, z can be any real number. So what is the intersect between them? The domain will be, you can have any x, y, z, but in this time 3-dimensional as a real number, but at the such that x second plus y second plus z second is going to be less than 9. That's the domain. Nothing special, same strategy. Okay, so one last, you could try. The bottom cannot be 0, we know that. And we know that inside of the radical cannot be negative number. So 2t minus 4 greater than equal to 0. So 2t, 4t is greater than 2. And x second minus y second cannot be 0. So x second cannot be 0, y second. So it means you can solve it. Y cannot be plus minus x. You can plug in the radical. So that's the 2 intersection. So domain will be, you can have any x, y, t such that y is not going to be plus minus x and t must be greater than or equal to 2. So that's the domain of the case. I'm pretty sure you can finish the rest of them. So I'm going to just show you this one. You're going to try this yourself. Just we have more variable going on, but the strategy is the same thing. So that's the half information. We finished almost information in 4.1. And the next one, I'm going to do the one more concept, level curves. So if you have, I'm going to show you 2 more examples. That's it. Can you show me your thumbs up? Are you guys okay so far? Finding domain and range in 2-dimensional space. Okay, so let me go down slowly. I see, yeah. So let's talk about level curves. Okay, what is that? So the definition of the level curve is here. Given a function f x, y, and then a number c in the range of f, a level curve of a function of 2 variables for the value c is defined to be the set of points satisfying the equation f of x, y equal to c. So it's a very same concept. You have a domain and you have a range that is corresponding. Just x, y. It's the same definition, but we have a little bit of context. You can plugging in and you have some number c. So f of x, y equal to c, but how that is related to the concept with the level curve of a function. So a little bit of background to understand this concept. I try to find out the example to talk about level curves. So if a hiker walk along logged trails, so we see this is a trail map, they might use a topographical map because in the mountain, right, you want to arrive on the top of the mountain, right? But it looks like you have a lot of layers going on, right? to get there. So let's say this is a topographical map, and then that shows how steeply the trails change, okay? So topographical map contains curved line. We have a lot of curved line. We call that as a contour line. So if you look at this image, I think this image is the best image to understand the contour of that level curves. So this is the height, this is the center, right? This is circle, still you have a center here. The next circle, the center is still same. The next circle, even though it's getting wider, 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 the center is still the same, right? Just the curve is getting wider, 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 or narrower, narrower, narrower. So this is the point of using topographical map. So this is the center. You're gonna find out. So there are many, you know, you can think about the coordinate points in the space. It could be 2-dimension, it could be 3-dimension, but there's always a corresponding z. So in other words, let's say I have x comma y comma z equal to, I don't know what the function, but it is corresponding to the center. Let's say it is a 0, corresponding to 0, okay? You're gonna plug in whatever the coordinate points. In this function, still give you the same center. But the corresponding number is getting wider, wider, wider. It could be happening. Center is still same. You can plug in any coordinate points, x, y, z, and then you're corresponding to another number, it's getting smaller or getting larger. But the fact that is you have a same function. So one more time, if I'm just creating the example. So let's say, I don't know, 1, y, z, okay? So let's say this is the function. You can have any x comma y. You can have a comma b comma c. The center is 1 comma 2 comma 1, isn't it? In this shape. And then we know that they're going to be corresponding some number. So depending on this coordinate points, you can have a smaller number, you can have a wider number. That's the size of this circle. Okay, that center is the same. No matter what you're plugging in, center is still staying. But your size of the circle is getting wider, 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 or getting back to smaller, smaller, smaller. So this is a little bit unique pattern we never seen before. So in this is happening only in 3-dimensional space. Center is a fixed. One of the variable is a fixed. No matter what you're plugging in, center is a center. But the size of another circle, the size of the circle is getting wider, 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 or smaller, smaller, smaller. So it's a little bit like abstract thinking though, but you can understand because it's literally the same concept, domain and range concept. If you're plugging in something, you will get something out. And then in this time, center is a fixed. So I will show you the example. Okay, a little bit abstract concept, but you got this. So let me just go to that example. Hold up there. So same thing, like you cut the tree, right? The next peel is getting wider, wider, wider. The center is the same thing, right? Yeah, no worry about that, Caesar. Thank you. So let's take a look at this one. This is one of the funky question, I will say. So I will show you my best to show you step-by-step work. So let's take a look at this. So here, okay, we have a given function. Thank you. This is 2-dimensional. We have only 2 variable. It's good to practice. So we have a given the function fx comma y here. That is a function. Find the level curve, okay, corresponding to c equal to 0. Okay, I got it. Then create a contour map for this function. What are the domain and range above? Okay, let's think about step by step. To find the level curve for c equal to 0, that looks a little bit funky, but we know that xy is equal to c. That's the definition of the function of the 2 variable. It could be z, it could be any number, but they just use a c. That's okay. But we know that c now is equal to 0. All right, and what else we know? Now this one is 8 plus 8x, 4y, 4x second, y second. Now that is equal to 0. Does it make sense? I didn't do any special fancy technique. I literally used the definition to find out some equation. They say f of xy is a given, and then c equal to 0. So therefore, this expression is equal to 0. So now we can modify a little bit. What I'm going to do, let me multiply square on both of sides to get rid of this radical. So then this one will be just 8 plus 8x, 4y, 4x second, y second equal to 0. Beautiful, getting simpler. Okay, now what I'm going to do, let's multiply -1 everywhere. Multiply -1 everywhere. So this is going to be -8, -8x, positive 4y, positive 4x second, positive y second equal to 0. So what I'm going to do now, change the order. I'm going to put the highest exponent first. We're going to rearrange each term, putting the x terms together. So x term 4x second first, minus 8x. And the next one, y second plus 4y. I'm going to move this constant to the other side, equal to positive 8. Are you following? I'm trying to find out some function. It could be circle function or whatever. So let's keep going. Oh, this one, do you remember? We can have a group pair. So this is X family, Y family. So I'm gonna do the factor for X second minus 8X. Oh, not 8X, it's gonna be 2X then. And then do you remember? Plus, minus the same number. It doesn't matter, it's the same balance. Hold up there. And then I do the same thing. Y second plus 4y. You're gonna adding and subtracting the same number. How do I find out that number? Equal to 8. You are going to look at that, 2. You're gonna divide it by that number by 2 and square of it. So 2 divided by 2 square, it's gonna be 1 and 1. 4 divided by 2 square, 2 and 4 and 4. Why am I doing this work? Because these 3 terms now, these 3 terms now, it's going to be a simple factor. Watch me. 4, what happened? This 3. X minus 1 to the second. And then we have a -1. I want to get out from the parentheses, so multiply with 4, -4. Plus this 3 term, y plus 2 to the second and minus 4. That is equal to 8. Are you okay with that? I'm trying to simplify finding the common factor. So x second minus 2x plus 1, that is a 2 binomial factor, x minus 1, x minus 1. Y second plus 4, y plus 4, that's also another common 2 binomial factor, y plus 2, y plus 2. So let's keep organizing. Now it means we have a 4x minus 1 to the second plus y plus 2 to the second. I'm going to move this 2 to the other side. So 8 plus 4 plus 4. Keep going. 4x minus 1 to the second. Y plus 2 to the second will be 16. And then I'm going to divide it by 16 everywhere. So you will get divided by 16, 16, 16. X minus 1 to the second over 4 plus y plus 2 to the second over 16 equal to 1. Da-da-da! What is this? If you go to one of the quadratic equation, this one you can go, I don't have that paper, but if you go to chapter 2, we talk about 2.7 quadratic plane. This equation exactly corresponding to ellipse. Okay, centered at where? 1 comma negative 2. So if you draw that image, it's ellipse. So 1 comma 2, 1 comma 2 here. And then it's going to be a little bit wider. So on the x-axis, you have 4 differences. And then you have to go to actually 2, because 2 square, 4 square. That this is a 2 square. This is 4 square. So from here, you go up to the y-axis. You're gonna go 4 more. So it's going to be something 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. So it's going to be something like that. This is ellipse, right? So what I'm saying is, this is the center, 1 comma negative 2. On the x-axis, radius is 2. On the y-axis, radius is 4. So this is ellipse. Okay? So let's keep going. This is the one. So now this is when c equal to 0. So what I'm saying is, hold up there. This function we just talked about, this function, when this function is corresponding to 0, you have ellipse. Okay, I got this. So this is the c equal to 0. Now you can change the c. You can increase 1. You can increase 2. So let me just keep going. So you can continue this work more and more. And what are you going to get? If you are getting wider, you can repeat this work. From here, you can change now radical 8 plus 8x minus 4y, 4x minus y second. Now you're going to set up equal to 1. And then do the same work. Find out the equation. And actually, if you do, I already calculate for you. If you calculate this work, okay, the function is going to be something this. So at the end, if you calculate it, 4x minus 1 to the second, 16 minus y plus 2 second over 16. Same thing, you will get 1. But here, actually, you have a different number, 15, 15. So it's going to be 15, it's going to be 15. If it's equal to 1. So you can keep on going when c equal to 2, c equal to 3. You will find out very interesting fact. What is that? In this equation, when c equal to c, the function creates the same ellipse at the center. It's not the same ellipse, just it's create the ellipse center at the same center. Sorry, at the same center. 1 comma negative 2, but different radius. It's getting wider, right? So the next one is going to be like something like here. So I'm going to change the color. The next one is going to be something here. This is the next ellipse. And this is when c equal to 1. So your level is getting wider. And at the end, I'm just showing you all the images. This is what's happening. No matter what, c equal to 0, c equal to 1, these are the corresponding outcome from the function, right? It's getting wider. But later, it's going to be just 1 point. But center is still same thing. That's what I'm saying. And then you can repeat the same word. The generalized of this function will be 4x minus 1 to the second, 16c second, y plus 2 to the second over equal to 1. You just keep changing the c. It's getting a little wider ellipse. but especially when c equal to 0, the denominator will be 0. 16 minus 4 second 16 is 0. So only center will be remaining. And then we call, what is that? We call this is level curves. This is the level curves, like age of trees, topographical map. You can find out the similar concept in many real life examples. So that's the concept level curves. Okay. And then what is a domain? Domain is going to be that. The domain, I'm going to write here, you can have x, y, such that x minus 1 to the second or y plus 2 to the second over 16 equal to 1. Because we had a c equal to 0 case. They did not ask you any other cases when c equal to 0. So that's the domain. But I just expand the information more. No matter what you are changing the c variable, the center of the shape is the same thing. Okay, so that's all about it. I'm gonna hold up here. Are you guys okay with that? Are you still there? Are you still there? So don't be scared. This is just, fun, concept. Just add this one into your knowledge. Okay, let's try the one last example like this. So that's why we talk about the level curve. So it's the same concept, same center. You just change the size of the, it could be ellipse, it could be circle. So check that information. It's also we call contour plot, but I just already showed you the example. So this is a similar example. You can change the k. It means it could be z, it could be c. So let x second plus 4y second, you can equal to k, right? And then now you have a 3 scenario. X second, 4y second equal to 0, x second, 4y second equal to 4, x second plus 4y second equal to 16. It's going to be ellipse though. So if you draw the image, you can draw the first one if k, this is if k equal to 0. This is when k equal to 4, right? This is a k equal to 16. So this is ellipse equation. So if you draw that, it is going to be, right? Something this smaller. This is k equal to 0. This is k equal to 4. The next is a 16. So in this case, it's getting wider, wider, wider as you keep changing the k. So this is ellipse. Okay. Very, very, very not that complicated. One last one. Letter B, same thing. If k equal to -1, 0, 1, 2. If y, what happened? Equal to, so I can do one last work, y minus x second equal to -1. So it means y equal to x second minus 1. Y x second equal to 0, it means y equal to x second. Y minus x second is 1. Y equal to x second plus 1. Y minus x second equal to 2. Y equal to x second plus 2. So if you draw this, we have a beautifully y equal to x second, right? So this is a k equal to 0. If it's a k equal to -1, you're going down 1 unit down. If you have up, you have up. So in this case, this is your contour plot. This is all your level curves in terms of this function. It may not be the circle all the time, depending on the given function. It could be ellipse, it could be circle, it could be parabola shape, things like that. Okay, so you can try the bottom one yourself, right? So the last one, same thing. If k equal to 0, if k equal to 1, if k equal to 2, we have a inside of the 4 minus x second y should be greater than or equal to 0. That means x second plus y second, that is going to be equal to less than or equal to 4. Did I calculate correctly? So positive, positive. So this is going to positive. Or let me change a little bit different way, because I don't want to make you confused here. 4 minus x second y second, let's say it is equal to k, right? So actually entire radical equal to k. So I'm gonna get rid of it. It's gonna be k second. So that means x second plus y second equal to k second 4 minus k second, right? Because I divided by -1, so 4 minus k second. So we are using this one. This is actually circle image. So just calculate that. So what happened if I do this work here? If k is 0, x second plus y equal to 4. The next one, 3. The next one is 0, isn't it? So the last one is only going to give you the 0, 0. So we have, you can draw in 2 or 3 dimension, doesn't matter. 2 dimension, you can draw the 2 dimension. So we have exactly 0, 0. This is when k equal to 2. So the question could be this in the quiz or in my final, find out the, image when k equal to 2. This is the answer because they have only point. All the center same 0, 0. Your radius is getting changed. So the next one, k equal to 1, a little bit wider, radius is 2. So this is k equal to 0. This is a k equal to 1. This is k equal to 2. So that's the image. Okay. So that's all about level curves. And then you can try the one more example yourself and choose the, image that is correct. Okay. So think about